All right, ladies and gentlemen, welcome to another edition of Science with Mama J. And I hope you guys had a fabulous Halloween and happy Friday. What I want to go over today is a little bit about protons, neutrons, and electrons and understanding the atomic model. So hopefully it'll help with the activities that we've been doing. So, first of all, there are 3 subatomic particles. Okay. We have protons, electrons, and neutrons. Okay, so protons, let's start with protons, are positively charged particles in the nucleus. They have a positive charge. And they're located in the nucleus, okay? Electrons are negatively charged particles. And they circle the nucleus. And neutrons have no charge. And they are in the nucleus as well. Okay, so now we have these 3 particles, both protons and neutrons. Have an atomic mass of 1. So an atomic mass unit of 1. So each one has an atomic mass of 1. So if I have, for example, a hydrogen atom has 1 proton in it, no neutrons, you'll see its atomic mass is 1.008. If you look at helium, helium has an atomic mass of 4.003 because it has 2 protons and 2 neutrons. Each has an approximate atomic mass. Now, we're going to get into in a moment why it is that there are decimals in the atomic masses of the periodic table. But for now, just know that the mass of the proton plus the mass of the neutron will give you the atomic mass. Electrons are negligible. They are so small that, and they move so fast around the nucleus that their mass isn't even figured in. Okay? So, these are the 3 parts of an atom. So now how does it look? Well, in the center of an atom, you have a nucleus, okay? And in the nucleus, you have the protons and the neutrons. So let's go ahead and pick the carbon atom. So carbon, for example, has, okay, we're gonna make carbon, has, for example, 6 protons and 6 neutrons, okay? Its mass is 12.001. So in its first shell, carbon has, and we'll draw the shells in different colors, it has 2 electrons, and in its second shell, it has 1, 2, 3, 4. Well, why is it structured this way? Well, there's a couple of things. On every element in the periodic table, the elements are neutral. And because the elements are neutral as they appear in the periodic table, the number of positively charged particles and the number of negatively charged particles have to be the same to balance them out. So when you're looking at an atom, you have to balance out and make sure all of the protons and electrons have the same charge. Now, this is what is called a Bohr model. So this is the Bohr model for carbon. We're probably going to get into the model names later. Okay? So a Bohr model for carbon shows all of the electrons in the first shell and all of the electrons in the second shell. Now, I know we've talked about the energy levels or the shells before, but let me go ahead and touch on it again. Okay? And if you look at the periodic table that's in our classroom, or you can look one up online that actually has the energy shells or energy levels, you can actually see how many energy levels there are. But looking at a periodic table, first of all, hopefully you remember the columns are the groups and going across are the periods. Well, each period has its own number of energy levels. So for example, period 1 that has hydrogen and helium only has one energy level. It has one shell. Period 2 from lithium to neon, it is in the second period, it has two shells. So if you go down the periods, period 1 through period 7, period 1 has one shell, period 2 has two shells, 3 has three shells, 4 has four, 5 has five, 6 has six, 7 and 7. Easy to remember, right? So the number of shells that it has where the electrons are distributed depends on what period the element falls in. So looking at carbon, carbon appears in period 2, okay? So as carbon appears in period 2, it has two energy levels. Well, how many electrons can each energy level hold? The first energy level, or shell, can hold 2 electrons, and I'll just put it as an E minus. The second can hold 8 electrons. The third can hold, and the third, when we're looking at the third period, it holds a maximum of 8 electrons. Okay? Now we're not going to go past the third shell. When we go into the fourth shell, things can get a little interesting because when you start getting into the transition metals, you'll actually see that you'll populate the fourth shell and then go back in and add up to 18 electrons in the third shell for all of the elements that are in the fourth shell. So things change a little bit. So we're only going to stick with the first 3. We're not going to work too much with those elements. Okay? But since we can only hold a maximum of 2 electrons in the first energy level, you see 1 and 1 is 2. And then the second energy level, well, carbon has 6 protons, so it has 6 electrons. So we did 1 and 2. So then we have 3, 4, 5, and 6. And that's how you populate an energy level. So we are going to go a little bit more into depth with this with the next video that I'm going to show, which is going to go over one of the activities that we did in class and actually show you how to create atoms on the atom board that we have. But the last thing I did want to talk about very briefly is ions and isotopes. So if we look at, for example, let's look at sodium. Sodium's atomic number is 11. Okay, so it is atomic number 11. So it has 11 protons, 11 electrons, and because its atomic mass is 22.99 or 23, it has 12 neutrons. We're going to get into the neutrons in a moment. But as we talked about previously in class, sodium wants to have a full outer shell. So since it already has 2 full shells and the third shell only has 1 electron, it's going to get rid of one of its electrons and have 10 electrons. Well, now, since sodium has 10 electrons and 11 protons, it becomes Na+. This is called an ion. So an ion is a charged particle. Now, a cation, running out of space, is a positively charged particle, and an anion is a negatively charged particle. Okay? And the other thing I said I was going to mention is isotopes, and I'll use the example that I did in class. Okay, so we were working with a lithium atom, and lithium has an atomic number of 3, and it has an average atomic mass of 6.94 atomic mass units. Okay? Now, one thing we learned about lithium is that it has 2 isotopes. Okay? So what that means is the number of neutrons change. And that's kind of like having a twin, where even though you guys are identical, you have a couple of characteristics about you that make you a little bit unique in comparison to your twin. So in this case, even though both lithium-6 and lithium-7 are both lithium, they do have some characteristics that change slightly. It's kind of like carbon-12 and carbon-14. Carbon-12 is very stable. It's actually what we use for charcoal and what diamonds are made of. But carbon-14 is radioactive and is actually used in radioactive dating. Okay, it's got a half-life of 5,730 years. And every 5,730 years, half of the mass of the carbon-14 will break down. So we use it to actually date organic substances that are less than 35,000 years old. So here we have lithium-6 and lithium-7. Well, as we mentioned, the atomic mass unit of both protons and neutrons is 1. So that means lithium-6 has 3 protons and 3 neutrons. This is for lithium-6. Lithium-7 has 3 protons and
Debbie
4
Keith,
neutrons.
please contact extension 1011. Debbie Keith, please contact extension 1011.
So, with 3 protons and 4 neutrons, lithium-7 is slightly heavier than lithium-6. Now, if you look here at the atomic mass, okay, the average atomic mass is 6.94. What this tells us with an atomic mass of 6.94 is that in the world, for naturally occurring lithium atoms, we have a much greater abundance of lithium-7 than we do lithium-6. So lithium-7, although both exist, lithium-7 is much more prominent and appears in the natural world more often. So I hope this video was helpful in helping you understand a little bit about how protons, neutrons, and electrons work and how to build the Bohr model. The next lesson we'll go into will actually show how we did it in a model so that you can understand it a little bit better. Have a fabulous weekend, and I look forward to seeing you on Monday.
Teacher, please run in.